to understand what we are going to do, we have to look at geostatic stress. Now, assuming this is our ground surface, so this ground surface, this is soil, right? Then let's take a certain depth. With a certain depth within the soil, we take a unit soil component. Now, with this soil component, there are going to be stresses acting on it. So we are going to have the vertical stress, and we are also going to have the horizontal stress. Now, here we are going to look at one-dimensional stresses. And so we are going to focus on the vertical stresses. Do you get it? Now, when we talk about geostatic stress, we are looking at stress as a result of geo, that is soil material or earth material. So, for instance, um, assuming you are carrying something, right? You are carrying, let's say, a bucket of water. Assuming you are carrying a bucket of water, right, on your head. So this is your head, and you are carrying a bucket of water. Now you realize that there's going to be a certain kind of weight as a result of the bucket and the water which is above you. And so in geostatic, as a result of the weight of soil above this point, which is our point of interest, there's going to be a certain force acting on it. Do you get it? Because it's as a result of the material above it. And that's what we call geostatic. Because the soil has unit weight, and so it's going to eventually have some form of weight, because it has a unit weight, then there's going to be what? Weight as a result of the material above this point. And that's what we call the geostatic stress. And it's given by the equation gamma z. You get it? Now, gamma is simply rho G. That is the how do you call it? The density of the soil, the acceleration due to gravity. So you can take the geostatic stress as a result of the soil has to be potential energy. You remember mgh as a result of the position. But here we are looking at, you see, in potential we are looking at altitude. In terms of geostatic stress, we are looking at in terms of what? Depth. Do you get it? Now, so if I want the geostatic stress, let me come. So if I want the geostatic stress that acts on a body, or sorry, on a soil at a given depth, let's say from here to here. So if I take this unit of soil at this depth V, what is the stress, or what is the geostatic stress acting on this unit of soil? And this is what we are saying that is given as this gamma V. Now, assuming there is water table, assuming there is water table, assuming there is water table, that geostatic stress is going to change. And so Terzaghi brought what we call the Terzaghi's equation, which is given by the total stress is given by the effective stress minus m plus the pore water pressure. So the stress at any given point within the soil is given by this. So if I want the effective stress is given by the total stress minus pore water pressure. Now, pore water pressure is simply the unit weight of water times the height of water. That is from the water table surface to the depth of interest. So this H is from the water table surface. So here it's going to be from this water table surface to the depth of what? Interest. And that is what our H. Now with this we can see that, let me explain these stresses. So the total stress, or the total geostatic stress, is simply as a result of the effective stress and the what? Water pressure. Now, in soil, we the strength of the soil is dependent on the effective stress. Now, the effective stress is as a result of the soil particles coming together. So, if the soil particles are able to come together, they generate what we call the effective wall stress. Now, if a soil has no water within it, then the particles will then come are very close to each other, and so the effective stress is high, right? But when there is water, assuming there is water, the water is going to displace the particles. Assuming there is water, the water is going to displace the particle because it will be passing through the tiny pores within the soil. You get it? And when stress is applied, it's going to spill. So it's going to cause the particles to move away. So in that case, the effective geostatic stress is going to what? Decrease. So pore water decreases effective stress. Now, if the effective stress is decreased, then the strength of the soil will also what? Decrease. All right. Now, we can also have several layers of soil. So, assuming this is my soil, I can have several layers of soil. So, let me use this color. Several layers of soil. So, this soil layer, and we have another soil layer. Now, if I want the stress at this point, because as a result of the weight of this soil, the weight of this soil, and the weight of what? This soil. So in this case, total stress on this soil is going to be the geostatic stress as a result of the first soil, this, plus the geostatic stress as a result of the second soil, which is this, plus the geostatic stress as a result of the third soil, which is also this. And that will be it. So let's take some examples, then we look at it.